So by now we have finished our model definition, and I have saved my file, and I have saved it as example model1.tcl. In my folder I also have the W section file that contains the procedure to build a fiber section, as you can remember from my last video. And in addition, I have the OpenSees interpreter that I downloaded from the website. So in this video, what we're going to do is we're going to be working with the gravity and the modal analysis. We're going to see how to determine them and how to read the results. So the first thing we're going to do is the gravity analysis. So basically, this is my gravity analysis. First of all, I start my analysis with these lines, initialize, to let know the OpenSees that I'm initializing my analysis. And then I'm writing just this line in order to have some feedback from the OpenSees to know that it's already running it. Then I'm going to do something very important, that is setting the recorders. So at this point, it is important to clarify that OpenSees only records or only remembers those parameters or those forces and deformations that you request to be remembered in advance. So for example, for my gravity analysis, I'm going to be asking OpenSees to remember the reactions. For that, I'm going to use a recorder based on reactions. Basically, the syntax is recorder based on a node. It's going to be saved to a file named gravityreactions.out. I want the first column to be the time. You might be wondering, well, there's no time in this static analysis. Well, for OpenSees there's always a time, and I will explain about this as I move on. So the first column will contain the time, that in this case are in reality the steps. I want to have as an output two different nodes. So I want node A0 and node B0 only, so I specify them here. And I want 3 degrees of freedom, 1, 2, and 3. So I want to know the horizontal reaction, the vertical reaction, and the moment. Now, this part here, I'm not going to go in depth with these values here, but basically what we're telling OpenSees is how I want the problem to be solved, what's my tolerance to error, what will be the convergence algorithm that this is going to do, how it's going to be solved, and based on what parameters we're going to execute the analysis. So for example, here I am using a load control, which means that what will be changing will be the load. I want increases of 0.1, which means 10% of the assigned loads that I did in the model. It's going to be a static analysis, and I want it to analyze it in 10 steps. So basically, when I put this plus 0.1 or 10%, and then I get these 10 steps, I am at the end getting the 100%. The first step will have 10% of the forces, the second step will have 20% of the forces, the third step will have 30% of the forces. You could add a 0 here and a 0 here and have 100 steps, or you can even reduce it to less steps, but this is normally what I use. Then at the end I am going to add these lines in order to reset the analysis. Now I am removing the recorders, for example, because I only want them to be used for this analysis specifically. I am not wiping everything. As you can see, I'm not using the command wipe, because sometimes I might want to do something after doing the gravity. For example, when I'm doing the pushover, I will do a gravity first. So that's why I am not removing this just yet. So this is my syntaxis for running a gravity analysis. What I'm going to do is, since the gravity analysis it's in a different file than the model itself. Here is the model, here is the gravity analysis. I'm going to open my OpenSees windows. There are many ways to run it. For me, I think the easiest one is to create a third file, and this is obviously optional, there are many ways to do it, in which I am going to request simply to assemble my model. So basically, source example model, which is the first file, and source analysis gravity, which is the analysis file. So basically what I'm doing is I am putting these two files together and making them a single one by using these two lines. So when I go to my OpenSees, in order to run it, what I will do is I will write the command source space and then the name of my file that I want to run, in this case run gravity.tcl. I press enter. As you can see, it's telling me here, yeah, I'm running the analysis, and actually has already finished because it's showing me a new line. And as you can see back in the folder, there's a new file here. This new file contains basically the recorders that we requested to be saved. So I'm going to copy these numbers and I'm going to paste them in an Excel file. This Excel file I will paste my values here, just Ctrl+C, Ctrl+V. In this case, as you can see, they are pasted as text, so I'm going to use this wizard and just press next and next, finish, and it will order the values. So in this case, the first column represents the time that, like I said before, this is the steps. The next three columns, they represent the results from node and A0, and the next three, they represent the values for N, B0. This one represents the horizontal load, so degree of freedom 1. This one is degree of freedom 2, and this one is degree of freedom 3. As you can see, at the end, for example, I have that horizontally, I have two opposite loads because it's a symmetrical problem. Vertically, I have the sum of all the loads that I have inputted into the model. And in the moments, I also have two opposing moments because it's a symmetrical problem. As you can see, when you have them in a text format, like in here, you can easily import it for other software, like for example MATLAB or Python, depending which one you use. You can easily read it and you can easily process this information in any of these softwares. Now, for the modal analysis, I'm going to do a similar process. I'm going to initialize. I'm going to put some text that I want as a feedback from the software. In this case, I'm going to put two recorders here and an extra recorder later in the program. So this recorder is based on a node as well. The name file will be this one here. I want the nodes NA0, NA1, and NA2, degree of freedom 1, and I want the value of the degree of freedom 1 on the first AHEN shape and on the second AHEN shape. I'm doing this in order to know the first and second shapes of this structure, so the modes of vibration basically. Once I have my recorders, I'm going to go to the analysis. The parameters, they change a little bit here. They're slightly different from those from gravity, and my analysis is made in this way. First, I'm going to open a file in which I will be writing. That will be also a kind of recorder, because I want these values to be written in a file. So it's another way to record the results. I'm going to execute an eigen analysis of the first two modes, as you can see here, with this 4 cycle. For each of these two modes, I'm going to find lambda, omega, the period, and the frequency. As you can see, they are all calculated here. And then I am going to display them in a table way. Finally, I'm going to close my file that I open back here, and I'm going to record the eigenvectors, and I'm going to finally reset or remove all the recorders and reset the time to 0. In order to run this as well, this is again optional. I'm going to create a file that is called run modal, because that's the way I prefer to organize things here. I'm going to write the name of the model itself and the name of the analysis, which means that in this case I am only going to be executing the modal analysis and on the model, but not a gravity analysis, because it's not here. So I'm going to close this. I'm going to open again my OpenSees, and I'm going to write source run modal.tcl. I do it, and I get these 3 new files. As you can remember, we had 2 recorders, are this one and this one here, that they basically show me 3 values only, that are the first, the base node, the first story node, and the second story node. And as you can see, this is just the modal shape corresponding to the first mode of vibration. This is the same, but for the second mode of vibration. Actually, one of them is negative and the other one is positive, like we would have expected it. Obviously, they are not normalized, so you can normalize them. And finally, I have this file that wasn't properly a recorder, but it was also an output from my analysis. That is this table in which I have the values for lambda, omega, period, in this case t, and the frequency. Again, these values from either of these recorders can be read by any software like MATLAB, or you can simply copy paste into Excel. In this case, again, using the import wizard, and there you have them. So this is how you do a gravity and a modal analysis.